Forgot. Welcome to the class. I'm Dr. Dan Kalish. We're going to talk about the GI effects test today. And so the reason why this is such a wonderful thing is that my main teacher and mentor, Dr. Richard Lord, developed this test, I don't know, 15, 20 years ago. And he started to think about this test probably 40 years ago. And the idea that one could measure the microbiome and understand what's happening with commensal bacteria and combine that with culture and with OMP and with looking for pathogens. This is really the culmination, this lab test is the culmination of decades and decades of research and work by all kinds of scientists and clinicians in the integrative and functional medicine community. And so it's pretty exciting. And I met Richard about 11 or 12 years ago, and he and I have had this one-on-one mentorship relationship where he's been training me in the interpretation of this lab that he built for quite some time. We've gone over my cases and my students' cases with this, and I feel like this is really a presentation about Richard Lord's work, and most of you won't probably have a chance to meet him because he's long retired now and living in a house by a lake in Georgia, and I'm really out here to try to communicate all the wonderful thoughts and ideas that he's had, many of which were encapsulated in this actual lab. So super excited to be here to be talking to you about this test. So in terms of me personally, I'm Dan Kalish. I've been training practitioners in integrative and functional medicine for about 20 years. We've got 7,000 people that have gone through the different courses that I've done. I've worked with the Mayo Clinic and done research with them on gut and adrenal function, actually, was that particular study. And I've been in practice forever and have been teaching for a really long time, and really mostly interested in lab interpretation and trying to bring this information to the next generation of practitioners. And that's really my goal, to get practices up and running with business skills and lab interpretation skills. And everything we do at the Kalish Institute is oriented in that direction. And so for you all, in general now, also want to present this offering that we have, which is for a boot camp that's starting in September. And you can, in the upper right-hand corner, you can just scan that code, grab your cell phone, scan that code, and that'll get you the 20% off discount, which we're offering exclusively to Genova Diagnostic practitioners. And so this is a brand new boot camp that I put together about the GI effects and goes into in-depth understanding of the lab and how to interpret the lab and how to design programs for patients that are going to be clinically effective. So if you're at the point in your career where you really want to put some energy into understanding the nuances of this test and how to apply it to your various patients, scan that code, join the class, and be super excited to have a bunch of you in the course. I always get excited when I teach a brand new class because I spent a long time trying to put these things together, and then to be able to release it to an audience, it's really the greatest joy of my life. So to be able to communicate all this information. So anyway, sign up for that, click on that QR code there, and you can get started. Then we're going to talk briefly about some of the background issues. Most of you know this, so I'm not going to spend a lot of time on these kind of slides. And then I want to try to cover off on the things that you may not be aware of yet that are incorporated into this particular lab. But we're all aware, I think, that a huge number of people, 40% of people worldwide, have some kind of functional GI disorder. And that is going to include heartburn, reflux, constipation, diarrhea, all these kinds of different problems. And I mean, it's not too hard to figure that out. If you're just talking to your patients every day, you know, people are complaining about GI things all the time. And so one of the issues with this test is that the way that Richard built this out, I'm going to show you the QR code again here. The way that Richard built this test out is so complicated. It's so complicated that it took he and I 2 years of working together to untangle what he really meant with this lab. And I confronted him about this week after week as we were working together. I was like, Richard, no one understands that marker. He's like, really? It means blah, blah, blah. And so what I want to try to do is just bring out the details of this lab that have in some ways just been hidden and lost in the haze of time, you know, because they're so complex. And Richard developed these things, but he didn't really explain them very well until I met him and just said, hey, my students want to know what this means. Can you tell me? And that's what this class today is all about, okay? So the gut bacteria, if you want to step back for a moment and just think about the biggest picture here, there's the microbiome, and it should be full of these good bacteria that are then controlling and dictating to a large extent what your immune cells do, what your brain does, what your metabolism does. And this is just one example of hundreds of these interactions where there's a gut bacteria over here, and it is going into your body physically and telling your immune cells what to do. It's not like suggesting what they should do, it's directing them. So gut bacteria go right in through the gut lining, okay, and they directly impact what your immune cells are doing. They're bossing your immune cells around. When you look at these interactions, it's phenomenal. And the same thing happens with the gut-brain connection and the gut metabolic or cardiometabolic connection. So these gut bacteria can control your rate of metabolism, whether your brain cells are going to grow well or not, and what your immune system does, just to name a few things. So the healthy gut microbiome turns out to be critical for avoiding neurological problems and chronic degenerative diseases of the brain like Alzheimer's, Parkinson's, and dementia. Turns out to be really important for avoiding weight gain and metabolic disruptions in prediabetes and insulin resistance and diabetes. Turns out to be really important for avoiding autoimmune problems and immune failure. It's a really, really important structure that we're talking about. And it's the good bacteria that should be dominating. And if that's not happening, and we'll show some examples of that in a moment, then you've got a world of pain that's potentially affecting that patient. You could have hormone imbalances, toxicity-related problems, depression, anxiety, fatigue. You could just toss out all the GI symptoms completely. Like, let me go back a slide here. You could just forget this whole slide and just forget all the GI problems. And really the main problem with microbiome imbalances is how it manifests in impacting other body systems. It keeps the good bacteria, keep the mucosal lining healthy, and when this starts to vary, you've got some really, really big problems. Now, the origins of the maintenance of this system have to do with pretty simple stuff, like a fiber-rich diet will create this mucosal barrier because the fiber feeds these good bacteria. And we're going to get into detail on this in a moment. So this is the mucus layer here, in that kind of pinkish salmon color. The fiber degrading microorganisms are in green, okay? And they're breaking up the fiber and turning it into factors like butyrate that are going to improve the health of the gut lining itself. You can have a few pathogens or gut bugs floating around, but if the good bacteria are dominating, they don't cause a problem. You're only going to have clinical manifestations of problems if the good bacteria, the microbiome itself, has diminished in its diversity and capacity to run all these different functions that it's supposed to be running, and then bad bacteria or infections like a Giardia infection, Cryptosporidium, E. histo, some kind of bacterial infection, yeast overgrowth, or parasitic infection starts to take a hold. And then things start to fall apart. And it all centers around what we're eating. Polyphenols and fiber are the key to keeping the microbiome healthy. Now, if everyone was eating fiber and polyphenols with every meal, and there was no antibiotics in the world, and there was no emotional stress and no environmental toxins, and everything would probably be fine, right? But that's, the vast majority of people that we test have problems with their gut, even if they don't have any obvious digestive tract symptoms. And this is the hardest concept. I don't want to dwell on it too long, but I'm just going to say this is the most important part of the talk right now. So let's think about it. I'll slow down for a minute and kind of focus my intention and delivery here to say that there's a subset of your patients that have GI symptoms. It's obvious that you should check them with a GI effects test. That seems pretty straightforward. However, if you have patients that have Parkinson's, autism, IBS, metabolic syndrome, problems with autoimmunity, kidney disease, liver disease, cancer, or anything to do with their cardiovascular system, if there's problems anywhere in there, then you're also going to want to check their gut bacteria. This is just one article out of tens of thousands about one organism, okay? And how Imbalances or dysbiosis, bad bacteria overgrowing in the gut, can be at the root of many of these different conditions. And so if the good microbiome organisms are faltering, bad organisms will take their place, and all these different health problems can occur. It's not just about digestive symptoms. So what that means, or where that translates into clinically, is that you should test everybody for their microbiome, whether they have a GI symptom or not. Every single patient needs to be screened because you just don't know, based on their symptoms, if they're having a problem with their gut or not. And this is the most confusing and difficult thing to get or to learn or to understand in functional medicine, is that we're not doing treatments based on symptoms. We're not doing lab testing based on symptoms. Of course, we're testing people with the GI effects that have GI problems, but we're testing everybody. I was told this almost 30 years ago by Dr. Bill Timmons, and he said, look, kid, he used to call me Danny Boy. He said, Danny Boy, you need to test everybody's GI tract. And I thought, I like this guy. He's an old guy. He's got gray hair. He seems really smart. He's a naturopath. He runs a lab. And I completely ignored him for like 4 or 5 years. I only tested people who had GI symptoms for GI tests because I didn't understand how to communicate to them the value of the test if they didn't have a GI problem. And boy, was I wrong. When I shifted my practice and I started to run GI testing on every patient, it opened up a whole new world of clinical competence to me. It like probably tripled my skill level just by ordering the test. I didn't know any more about what to do. I just was testing everybody who had Parkinson's, autism, metabolic syndrome, autoimmune disease, this whole list, just testing everybody. You have a history of cancer, we're going to do a GI test on you. You have a history of a degenerative brain disorder in your family. Not even, you don't have Parkinson's, but your dad did. We're going to test you. We're going to test everybody for this, okay? And if you can get that concept down and you can start to test everybody, maybe it'll take you 4 or 5 years from today to actually do it like it took me. But with listening to Dr. Timmons, but it'll transform your practice overnight when you can do that, right? Okay, so now, oh, and by the way, to answer Brittany's question, competitive athletes, are you kidding? I've worked with hundreds of professional athletes, and their microbiome matters to them like gasoline matters to a race car, okay? If the more tuned in you are, if you're an athlete, the more important your microbiome is. This is important. It's important for everyone. It's important for women that want to have a baby. It's important for women that want to start a law firm. It's important for men that are older and kids, and the spillover is to everyone that we're working with, okay? So we're going to talk about how these problems develop before we start to look at some of the labs. In a healthy individual, which we don't ever see, at least I don't see in my practice, they don't come in, you have a diverse and resilient microbiome. There's all kinds of different good organisms, and they're enjoying one another's company. It's like when you have a really great dinner party at your house and you've got 12 of friends that don't know each other and they're all kind of interacting, and you're like, wow, this is a really great time. There's different organisms. Some of them have a lot, some of them have a little real estate in your gut. Some of them are taking care of your heart. Some of them are taking care of your immune system. They're all kind of living a life together. There's diversity, there's resilience, and that's, again, we don't see that in practice, but that's what our goal is. The unhealthy lifestyle, the emotional stress, the physical abuse and sexual abuse that people endure, the environmental toxin exposure, mold exposure, eating poor quality food, obviously, picking up infections when you're traveling in your gut. All these things conspire to create an unhealthy microbiome. And because this test is so complex, and because most of us don't have the brain power and 30 years of study in this area that Richard Lord does, I think it's sensible to break this down to 3 stages so you can wrap your mind around how to communicate this to your patients. Stage 1 is a microbiome disruption. Stage 2 is something wrong with the GI organs. And then stage 3 is an infection. And when you look at these labs, as complex as they may be, you're just trying to answer 3 questions. That's it. Is the microbiome good or not? Disrupted, inflamed, good, or is it in beautiful condition? Yes or no? What's going on with the microbiome, good or bad? Is there a problem with any of the GI organs or the immune system in the gut? That's all on the test. That's a yes or no question also. If there's a yes there, then which organ is it? There's only like 4: your stomach, your pancreas, your gallbladder, and your intestinal tract. So is there a problem with one of those organs? Yes or no? And is there any kind of GI infection? Is there dysbiosis, yeast overgrowth, H. pylori, or parasitic infection? Just answer those 3 questions, explain which of those 3 problems is going on to your patient, and you'll have it made, okay? That's all you really need to do. So now, in terms of the process that we're looking at here, and this is a little dicey in terms of it's a little sciencey, but I think it's worth learning. So you have your plant particle. That's called a vegetable or fruit, or grain. And there are primary plant fiber degraders. That means there are bacteria in your gut whose main job is to break down fiber that you eat from your diet. Super straightforward. If that process is not happening, everything else on this slide gets undermined. Everything else. If you don't have the fiber and you don't have the organisms to break down the fiber, then you're going to have problems with short-chain fatty acids, problems with your mucosal gut lining layer, problems with the tissues healing and repairing. The tissues are going to be inflamed. You're going to have a lot of oxidative stress. All these different problems on this slide stem from the lack of plants in the diet, the lack of fiber, and the lack of polyphenols. And we'll get more into detail on that in a moment. The lack of fiber and the lack of polyphenols. And so fiber is fiber. I think that's pretty obvious. The best source of fiber, if you're wondering, for humans in general is considered to be beans. That would be lentils, black beans, pinto beans, hummus. Doesn't really matter. Lentils are considered to be the best, but any kind of bean is going to have the fiber that we're talking about. And then the second thing that these organisms need to live on would be polyphenols. And my favorite polyphenols I eat every day. Blueberries, not all of them, but one of them. Blueberries, pomegranate, and cranberry. Easy peasy. I mean, how hard is it to consume those foods? It's not. And there are many other foods, obviously, that have polyphenols in them, but the berries are the richest, easiest, convenient source of them. If you eat the polyphenols, then what's going to happen is the good gut bacteria are going to start to grow out. And we can measure this on the different metabolomics type tests like the NutriVals and the metabolomics that Genova has. And I'll show you these polyphenol markers later in the class when we review some labs. So you can test for the sufficiency of polyphenols in the patient's diet. And these, along with fiber, are what are going to create a good gut microbiome, which in turn is going to have anti-cancer effects, anti-diabetic effects, anti-inflammatory effects, keep your brain healthy, and keep your heart healthy. Polyphenols and fiber are going to do that. And we can measure for all this. Between the GI effects test and the metabolomics organic acids testing, you can test for all this. So you're not guessing, right? And here's an example of those tests. The dysbiosis markers, and you can see the ones that are polyphenol related because they have phenol in the name. Not all of them do, but these do, like here, hydroxyphenol, you see the phenol there? Hydroxyphenol, see the phenol there? Dihydroxyphenol, these are polyphenol markers as well, benzoic acid and hippuric acid. All right, so if these markers are categorically low, you have a problem with not enough polyphenols in the diet. If these markers get a little sketchy and a little too high, it can be overgrowth of bacteria, which is not a good thing either. So you want them solidly in the green zone. Kind of in the high range of the green zone is considered ideal. Okay. So fiber in the diet can be measured with butyrate, and we'll see that in a moment. And then the polyphenols in the diet can be measured with these markers. Okay. And the butyrate markers and short chain fatty acid markers are on the GI effects test. So what treatments for various lab markers? You want to learn now, and I just said it, so I kind of cheated, you already got the answer. What are the lab markers that show when soluble fiber is essential? That would be if the person's low in the good bacteria or if they're low in short chain fatty acids. Which lab markers indicate polyphenol supplementation is essential? It's the ones we just looked at here. Benzoic acid, hippuric acid, if these are categorically low, then you don't have enough polyphenols in the, or if you have the commensal bacteria on the GI effects test are low, that'll tell you need more polyphenols. So these are the treatments, fiber and polyphenols, and all the supplement companies have these. You can just get them and give them as you're working on the patient's diet. You can supplement in the short term. And then we can talk a little bit about that sulfur compound. So again, stage 1 is the microbiome. Stage 2 now is going to be there's an organ-related problem. If the microbiome's been screwed up for long enough, eventually the organs are something's going to happen. You're going to have not enough stomach acid. You're going to have not enough pancreatic enzymes, not enough gallbladder production of bile. You're going to have a problem with the immune system in the gut or inflammation in the gut lining. So there's going to now be organ involvement, and that's what I would call stage 2. This is not a disease process yet. It's just a functional problem. It's not a failure of the pancreas that leads to someone dying for any reason, right? It's just the beginning of the problem. That's why we call it functional medicine, right? It's not pathology. It's the beginning of the dysfunction. But it means that the microbiome's been out of balance for a while typically, and now the organs are taking a hit. So that's what I call a stage 2. And again, pancreas, the gallbladder, the immune system itself. Stage 3 is this has all been going on for a really long time. The microbiome's not been great. There's not enough polyphenols in the diet, not enough fiber in the diet. The immune system's not doing well. It's inflamed. The organs aren't doing well. And now the person's natural immunity is weak, and they start to have problems with infections. H. pylori, blasto, giardia, crypto, E. histo, yeast overgrowth. It just goes on and on. But when you get to that point where the infections are a problem, it's because the microbiome was disrupted and the organs aren't working well also. You can't, it's rare that someone just gets an infection out of the blue that becomes chronic in their gut. Most of the time, if you're eating at a divey restaurant somewhere and you get some giardia in your gut or something like that because you ate, or you're camping and drink some water that you shouldn't have drunk, and you get giardia, your immune system should clear it. Of course, you're going to get sick, but a few weeks later, it should be out of your body. If you can't clear that giardia from that bad water you drank, that's because your immune system's not working right and your microbiome's not right. So the infections that become chronic are a consequence or a sequela of the organs failing and the microbiome failing. That's the whole point. And so you can't just treat the infection. You just can't say, oh gosh, you have H. pylori. We're just going to kill that H. pylori and you can eat whatever you want and we'll leave your microbiome alone, even though it's all screwed up. And we're not going to talk about enzymes or anything for your gut. You have to think about the infection being the final stage of this 3-stage process. And we hear this in class all the time. This just happened this morning Okay, one of our doctors in the mentorship class, she's like, I've got this new patient. They have H. pylori, and it's been treated several times, but no one can get rid of it. And I'm nervous. I'm not sure what to do. I'm like, okay, this is good. This is really good. Did this person deal with their microbiome and fix that and deal with all the organ-related and immune-related issues first? And she's like, no. I'm like, well, you can't just go after the infection and think that the program's going to work. You have to be systematic and correct the body in every regard to which these problems occur. Dysbiosis, that's another one. And here we go again, feedback loops. The one can make the next worse, and it just goes on from there. So in other words, once you pick up an infection that you can't clear, that's going to make your microbiome even worse. And most people that we work with are in this sort of downward spiral of all this stuff. Man. The main point to remember here is that when you look at the lab, just answer these 3 questions. Microbiome, good or bad? Organs, involved or not? Infection, yes or no? That's it. Just those 3 things. That's all you need to do. Stage 1, stage 2, stage 3. And it's progressive. Stress and poor diet kick this thing off. The organs get nuked. The pathogens start to appear. So when we're looking at the disturbed microbiome, this is the portion of the lab that Richard spent all those years working on. These are the commensal bacteria. And it's very difficult even to pronounce many of these organisms, let alone to really understand what they mean. And this, when I first met Dr. Lord, this was my first complaint, because he was saying, I spent my whole career creating this microbiome test because I wanted clinicians to know what's happening with the gut. And I said, well, you know what, Richard, the reality is everyone skips over that page because no one understands it. And you got to realize he's Georgian, he's a Southern gentleman, and he didn't get mad, he didn't react in any way. But you know what? About a month later, he had produced a 200-page book in response to my comment. I'm not kidding. You can buy it. You can go online and buy it if you want. It's a book basically about this test. Uh, Richard S. Lord. You can look it up. You can get it from Google Books or Apple Books. And it's a book explaining what he really meant, which was that this matters, this page matters a lot, and here are the different connections between these organisms. And that's what I want to talk with you guys about now. Not an individual marker, but the biggest view that you can have of these commensal bacteria. Because you don't need to memorize each one and be able to pronounce Faecalibacterium prausnitzii and say it 10 times. You just need to understand the dynamic that we're going to be viewing on here, and I'll describe that to you in a minute, okay? So then the stage 2s are easy to identify because the lab just tells you, okay, there's a problem with your immune system, there's a problem with inflammation, there's a problem with your gallbladder, there's a problem with your stomach. There's no complexity there. You just need to know, okay, there's a gallbladder problem, I can see that marker, I'm gonna give them gallbladder support. There's a problem with the enzymes. I can see that on the lab. I'm going to give them some digestive enzymes. Okay, so that's relatively straightforward. Pancreatic elastase, I mean, it's got pancreas in the title there, right? So if that one's off, like it is on this test, you just give pancreatic enzymes or give digestive enzymes, a broad spectrum digestive enzyme to solve that problem. Okay, if you see a problem with anything to do with the gallbladder, fecal fat, etc., then you can give gallbladder support. And if you see inflammation or immune reactions, you can give the different powders that are anti-inflammatory and immune enhancing. And I have a whole list of those I'll show you in a minute towards the end. So it's really straightforward. Inflammation, give the anti-inflammatory powder. Immune problems, give the immune powder. Gallbladder problems, give the gallbladder supplement, and etc. And then down here, it's a little complicated under butyrate, under short-chain fatty acids. But if any of these markers are really not doing well, you can give butyrate as a product, okay? And there's 2 or 3 companies that sell good quality butyrate now. Just make sure you get one of the newer brands, not one of the older ones. When butyrate was first around 30, 40 years ago, it didn't work very well. But there's several companies that have developed new forms of butyrate that are incredibly effective, okay? And so that's it for that section. And then stage 3 is the easiest because they have a pathogen, you're gonna wanna kill it. But it's really the hardest because you have to contextualize why the pathogen is there. It's there because the microbiome hasn't been working for a while and the organs are screwed up. So you have to address the microbiome and the organs if you want to have any chance of getting rid of the pathogen. And the pathogens are, again, H. pylori, Giardia, Crypto, E. histo, yeast overgrowth, dysbiosis. It's a whole variety of them. And we definitely want to kill the pathogens. I'm all for that. However, you want to be strategic about it. You don't want to just say, oh, you have blasto. We're just going to kill the blasto. When are we going to start? Oh, tomorrow. No, let's start today. You buy all the... No, you don't want to do that. If you want to go after an organism, you have to be a planner. I think a lot about World War II because I used to read about it when I was younger. And one of the most important events for Americans in World War II was obviously the invasion of Normandy, or called D-Day. And did they just take, like 400,000 or 500,000 people and throw them onto the beaches of France? No, they obsessed for like a couple of years. They planned this thing out really, really carefully, really, really carefully. And then they launched like a couple 100,000 people on boats and all these people in the air. And then they had in total, maybe almost 500,000 people attacking what were maybe 50,000 Germans. So it wasn't much of a fight. In a few days, in some places in a few hours, it was over because there was 10 times more Americans and Brits and Australians coming in than there were Germans trying to fight back. You want that kind of attitude when you go after a pathogen. You don't want it to be a fair fight. You don't want to find H. pylori and then the next day try to kill it. That is not what you want to do. That won't work, or half the time it won't work. Your odds on it working are greatly decreased if you rush into it. You want to plan and be strategic. And how do you do that? By strengthening the immune system and the organs, and by strengthening the microbiome. Then you go after the organism. And just like the Allies crushed the Germans in World War II at the beaches of Normandy, you want to just completely eliminate that H. pylori. No question about if it's fighting back or not. But you have to have overwhelming odds. You have to have an upregulation of the immune system in order to do that. So one of the more common mistakes I see is the patient has a pathogen, the doctor gets overly excited, and they're like, oh, you have H. pylori. Well, here you go. Take these herbs, take these antibiotics. Good luck. No, 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 no. You got to plan and you got to treat the underlying conditions that predispose the person to have the infection. The infection's the last thing you want to deal with. And if you wait and you're strategic and you plan, your results will be incredibly better than if you don't. I try to always remember to talk about E-histo. This is a very special infection. If you ever get a patient with E-histo, you should panic a little bit and freak out. If you're not in my mentorship class, just send me an email and maybe I'll have some time and I can talk to you about it on the phone. But E-histo has a very special place in all these pathogens and it needs to be treated very carefully and very seriously, okay? That can cause a lot of problems. So this is just my little call out for E-histo there. All right, so what are you looking for within these 3 stages? You're looking for disruption of the normal bacteria, for stage 1. You're looking for evidence of poor digestion for stage 2. That's elastase, pancreatic elastase, the fat stain, carbohydrate markers. You're looking for degradation of the immune response. That's lactoferrin, calprotectin, Sig-A, those kinds of things. And for stage 3, you're looking for parasites, bacteria, and yeast. Now, that's the analytical framework. Now, we're going to all take a deep breath. You could stretch. I should stretch. I've been talking for 35 minutes. Now we're going to get into what, is the really interesting part of this, right? This is really, 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 really interesting. And this is what Richard and I spent 2 years talking about. You ready for this? Okay, here we go. If you understand this conceptually, you'll have the microbiome down like no one else. So there's a cycle here. It starts with dietary fiber and polyphenols. They should both be in there, but we'll just talk about fiber for now. There are organisms in your gut whose job is to take that fiber and use it as a food supply. And those bacteria have a waste product that is a fat. It's from fiber to fat. How that is possible, you'd have to get a degree in microbiology to fully appreciate that there are bacteria in your gut that are friendly, that are taking that dietary fiber from all those beans that you ate and converting it into fatty acids as a waste product. And they're just spitting out the fatty acids for you. And that butyrate, acetate, propionate, these fatty acids, these short chain fatty acids, are the main energy source for your intestinal cells. And the butyrate part of this whole thing is one of the most important things for brain health. I know that sounds crazy. Look it up. Butyrate ends up going to the brain and it stimulates BDNF. Believe it or not, I know that's crazy, but that's what happens. So it's important for your brain cells to grow out properly. It's important for the anti-inflammatory effect. It's really, really important for your immune system. So these short chain fatty acids, these are fats that are made by bacteria because you eat fiber. If you don't eat the fiber, you don't get the short chain fatty acids. They're just not floating around in your body. They have to be produced by these good bacteria. Okay. Once the short chain fatty acids are produced, that's half the battle here. There are also bacteria that make hydrogen in your gut. Different bacteria, some of them do several different things at the same time, but in generally for simplicity's sake, we'll just call them different bacteria. Those hydrogen producing bacteria feed and supply the hydrogen consuming bacteria, okay, which are essential for your health. And as the hydrogen consumers consume hydrogen, it creates more space for the hydrogen producers to grow. See that? So it's this cycle that starts with food. If you don't have fiber in your diet, then none of this is going to happen. And now you can see why so many people have problems because they don't eat enough fiber. So butyrate producers, the sentinel of the gut. The butyrate producers, what does that even mean? So butyrate is a short chain fatty acid. You can buy it in a supplement form. The butyrate producing bacteria, here they are. And once they make that butyrate from the fiber, here are all the wonderful things that can happen. Anti-inflammatory molecules, anti-carcinogenic molecules. All these different things happen from the good bacteria, vitamin B12. all these good things. And here's our butyrate over here, okay? This all stems from that one set of bacteria growing out properly. And I'll read this one little quote here. Butyrate-producing communities, or bacterial communities, also produce various bioactive molecules that are antimicrobial, anti-inflammatory, and anti-carcinogenic in nature. And you can take butyrate in the beginning of a patient case just as a supplement to cover over things, but obviously eventually you want to do it all with diet. There's the gut-brain connection that I alluded to a moment ago. And you just can't even believe that this stuff is true. From butyrate, when butyrate gets into your brain, it stimulates brain-derived neurotrophic factor to get brain cells to grow. Like, you couldn't make that up even if you were just thinking about crazy things that could happen in the body, you know? It's incredible. Your brain is dependent on the butyrate that the bacteria in your gut are making, and that's from the fiber. So if you eat fiber, complex carbohydrates, your gut bacteria grow, you get the butyrate, propionate, acetate, all these really wonderful things happen in your body, including it has this direct impact on your brain. Go figure. How is that even possible? And I just throw this in there. You can take a snapshot of it if you want to read some of these studies, because it's kind of interesting. But anyways, these are just citations, so you can look through these later if you want, right? So now, here's another one. Oh my gosh. I really like this stuff. But let's try to simplify it, because I don't really probably want to bore you with all the details here. But again, complex carbs, right? Going into this whole process. And the net result of this is that the gut lining is maintained. All these gases are produced, and really good things happen. You can, again, take a snapshot of this citation here and read about the details on it, okay? So now, there's broad categories that you just want to have in the back of your mind. You don't have to memorize this, but you should know that this is what's happening. There's high abundance, non-hydrogen producing bacteria. That means there's a lot of them, high abundance. Non-hydrogen means they don't make hydrogen. And this class functions at the top of the gut microbiome food chain, degrading a wide variety of complex carbohydrates to simple sugars. That stimulates the growth of hydrogen producing bacteria called hydrogenogenic bacteria, and hydrogen consuming bacteria called hydrogenotrophic bacteria. So if you read the research studies, they use these fancy terms, but all they're really meaning is there's hydrogen producing bacteria and hydrogen consuming bacteria. But the top of the food chain that's triggering this are the ones that deal with fiber. And when you look at the labs in a minute, you're going to see all these bacteria listed out. So here are short chain fatty acid converters, right? The ones that convert fiber to fat. Bifidobacterium, Faecalibacterium prausnitzii is probably one of the most famous, especially these days, because Faecalibacterium prausnitzii shows up in the long COVID literature all over the place. This one's become really important since COVID hit. So you should be aware of Faecalibacterium prausnitzii. Lactobacillus, these are the ones that are converting fibers to sugars and short chain fatty acids. These are commensals. These are good bacteria converting fiber to fat. And here they are on a test. You can see them. I'm just highlighting them there. So you have I'm measuring these. Faecalibacterium prausnitzii, lactobacillus. These are the ones that are converting fiber to fat. And they appear in very large numbers. They're abundant. There's large numbers of them. And we already kind of stated that. We'll skip over that. Now here are hydrogen producing bacteria off the test. You don't have to memorize this. You just know this is happening. So that first group is helping this group function well. Okay? They're hydrogenogenic. They're making hydrogen. And hydrogen turns out to be very important. And here they are on the lab, the hydrogen producing ones. Again, I wouldn't even bother memorizing this, just conceptually, so you can talk to patients about this. Why do these bacteria make hydrogen in the first place? So when humans are making energy, we use oxygen, and then we burn the oxygen as part of the production of ATP. And then we take that extra hydrogen from the oxygen burn, right? That happens in the electron transport chain and all the stuff that goes on in your mitochondria, and end up making water and CO2, and those are like the waste products. So in your gut, it's a little different because there's no oxygen. It's an anaerobic environment. So they have to do something with the hydrogen, and they can't just slap it onto a water, okay? And so they grab another hydrogen molecule and they go together and they end up making hydrogen gas. So that's solely a result of the fact that your gut, your large intestine is anaerobic. So we make CO2 and H2O as part of our energy production process. These organisms make short chain fatty acids and hydrogen, just part of their life cycle. The key part, though, is that hydrogen gas isn't just randomly there. There's this whole other group of good bacteria that have to have that hydrogen gas to survive. And then there's all these other effects that I just went through on what butyrate does. So if you don't have hydrogen gas in the GI system, it's like you as a human are not breathing. This is really, really, really important to have all these things. Without these, the GI system just is going to completely fall apart, and then that's going to drag down your brain and your heart and your immune system, all these other things, right? So again, 3 different groups. They make short chain fatty acids, they make hydrogen, they consume hydrogen. And there's some other random ones that do things like live on sulfur and have funny other functions, okay? These are hydrogen consuming bacteria that are on the test. M. smithii, D. piger, and probably the most famous of these, Akkermansia muciniphila, okay? And here they are on the test, D. piger, M. smithii, Akkermansia. And this slide here kind of tells you a little bit about the detail of what they do. So M. smithii, anti-inflammatory, D. piger, important for cardiovascular disease prevention, Akkermansia is kind of important for everything. Okay, and there they are in the lab. So again, here's a little note on how these organisms deal with hydrogen and archaea and all this good stuff. Akkermansia is kind of like Faecalibacterium prausnitzii. It has a extra special role, and so you should read a little bit about it, you know. And then when you're presenting these labs, you only need to know like 5 or 6 of these organisms. I wouldn't memorize all 24. Just have talking points on 5 or 6 organisms so you can speak intelligently about the microbiome to your patients. And I don't know, well, you can tell my favorites just from this presentation. I would learn these 3, like M. smithii, D. piger, Akkermansia, and you kind of, I don't know, pick another 1 or 2 of your favorites. You don't have to use my favorites. You got to know Faecalibacterium prausnitzii though, because of long COVID. So there's 4 right there, you know, that you should read about an hour on each one and just have some stuff you can tell patients. Oh, this one does that. This one does this. This is why this is so important. But don't try to memorize them all. It's unnecessary. It'll just confuse your patients. Talking about 3 or 4 of them is plenty. Okay. But Akkermansia is one. This is implicated in obesity. Everyone cares about Akkermansia. And atherosclerosis, so that one's important, right? And then the lifestyle changes, I mean, you can put this together already probably. You're supposed to eat fiber and eat polyphenols and be relaxed when you eat, you know, and make sure that you're feeding these organisms. You're giving them the breath that they need, right, which is literally fiber and polyphenols. That's all you need to do to start this whole thing off. And these are kind of reiterations on this. Now, here's some treatment options. If you want to get nitty gritty about it, you know, individual organism, what should I do kind of stuff. You can grab a snapshot of that if you want. But I don't usually use this chart. You know, I think the more general terms are really what we're after. The fixing of the polyphenol issue and the fiber issue, and then the organs, and then treating the infections. But some people like the details, and I always get asked, what do I do for this? So you can like use this as a guide if you're one of those kind of people that likes the details. And then here we go. We're going to identify, when we look at the labs now, when is soluble fiber essential, when a polyphenol is essential, when are you going to use sulfur? That's for D. piger. You can use sulfur compounds to treat that. That's on the list here, okay? And then mucin repair is Akkermansia. And then this is really obvious. If these markers are low, you can use butyrate if the short chain fatty acid markers are low. And here are some protocols then to start to think about. Prebiotic powders are great. Fiber is great, obviously. Probiotics and butyrate. These are the 3 different treatments that I'd recommend you use when you see microbiome imbalances. It's all based on what we just talked about. It shouldn't be too confusing. And then if you have an organ issue, if it's stomach, give betaine HCl with pepsin. if it's gallbladder, give digestive enzymes and gallbladder support, you know, so it's just a one-to-one there. If it's a lower GI problem, you can use a GI repair powder that's anti-inflammatory if they have a lot of inflammatory markers. You can use an IgG-based powder if they have a lot of immune problems on the markers. So I don't know how many there are here. There's maybe like a dozen products you need to know. Not any more than that, really. And then if you get into an infection, then you want to be able to treat the infection. And then, okay, let's talk about the boot camp. A couple of you already asked me to show the QR code again. So there it is. You can scan that. That gets you 20% off this 6-week class on the GI effects that takes everything that we're talking about now, but actually shows you how to do it. And what I want as an assignment for all of you that sign up for that class, you should run out now and get a GI effects test on yourself, okay? If you just ran one on yourself, then you can submit that too, because we want to review your labs in this class, either your labs on yourself or your lab, if you haven't tested yourself in the last year or two, test yourself, or your labs on obviously your patients too. So this is a lab review course. It's not like we're going to sit around and talk about Akkermansia all day. It's like, I want to see the labs. Let's just start fixing stuff and see what you guys can come up with in terms of developing solutions, all right? And we're getting almost all of the doctors, chiropractors, acupuncturists, nutritionists in these courses now to test themselves. And it's the best thing ever, because a lot of people feel fine, but they look at their gut and, you know, it's a big problem. Okay, so I'm going to do one case in the remaining 9 minutes. Then I'm going to stop, take a sip of water, and the class will officially be over. But then I'm going to open it up to questions, and you guys can ask questions, all right? Whatever you want. So you can type your questions in there and I'll try to cover them all. But I want to keep it to the hour deadline because a lot of you probably have other stuff you need to do. Okay, so let's take a look at the case I prepared here. Let me get the right button clicked. And oh, let's start with this one here. Here we go. Okay. Oh, let's do this one. This one's a little harder. Let's do a harder one. Okay, so here's a GI effects test. The front page is a summary of all these things. And I always look at the front page because it's the algorithm they have running on this is pretty accurate. So it gives you a really good orientation to what's happening. Sometimes it misses a few things, but most of the time this is pretty darn accurate. It's hard to set up these algorithms too. You got to appreciate how much time it takes for the science team at Genova to do that. Like, it's really hard. There's a lot of computing power and brain power involved. And then we're going to look at the hard part here that here's the commensal bacterial section, remember? And the talking points on this are that you want to know, are the short chain fatty acid producers okay? Are the hydrogen producers okay? And are the hydrogen consumers okay? And if one of those is off, do you give a specific individual treatment for that one bacteria? No, because the whole point of this talk is that they're interconnected. Where does it start? Fiber and polyphenols, right? You get that? And then, of course, you want to fix the organs and get rid of the infections as well. But this is really going to come down to lifestyle and what people are eating. And in the short term, I always use prebiotics, probiotics, and butyrate just to get that patient better. But we want eventually for their own body to be taking that over and doing that on their own. And then I'll circle my 4 favorites. You should develop your own 4 favorites, but if you just want to use mine, that's fine. You know, Deep Hydra, you should know about that one. M. smithi, Akkermansia, and Faecalibacterium putznitzi because of the long COVID connection. So those are the 4 that I've read a lot about. So, you know, and usually one of them is off. So it gives me talking points because you want to be able to talk about the microbiome and you want to pull it back to the lab. So you can say, gosh, your Deep Hydra levels are undetected. Your M. smithi levels are undetected. DL means underneath detected limit. That's an issue. Let's talk about what these organisms do in terms of cardiovascular health and metabolic health. And I know you want to lose weight and you're worried about your heart, but this is really important stuff. And then how are we going to restore these organisms? And you talk about the life cycle and how fiber feeds to the fatty acids, to the hydrogen producers, hydrogen consumers. And then this is the strongest argument you could ever have for people starting to eat healthy food. You know, it really is. And then you're going to supplement in the short term to get them better. And let's take a quick peek here at what else is going on in this lab. So there was also a parasitic infection, some yeast overgrowth, and the Sig-A was kind of high. So let's look at a program design for that. Just to give you a rough idea about how you can design programs. All right, so now let's just state the problems. Well, the microbiome was disrupted, right? So microbiome disrupted. There were a parasitic infection and yeast overgrowth. Sig-A was off, so that's immune system and gut. Oh, I think there was a gallbladder problem, right? There's a fat problem. So let's call it gallbladder. And let me reorganize this because I've kind of got the numbering off. Let's do it like this. So it makes more sense. So, because now we can look at it in terms of these stages or phases. So stage 1, the microbiome is disrupted. What are we going to do? That's our prebiotics, probiotics, and butyrate. Sig-A was off, so you want to use an immune powder, right? Immune powder for the gut. And the gallbladder was off, so you want to use gallbladder support. Every company will have a good gallbladder product. Parasites and yeast, strategically and a little bit later, you're going to want to kill these organisms either with prescriptions or herbs. So let's just say antimicrobial. And there's many reasons why you might use a prescription versus herbs, just depending on the situation. We had a patient this morning in class. As a matter of fact, I can show you the lab because I pulled it up. How handy is that? Here's the actual lab. And check this out. Well, first of all, look, short chain fatty acids low. Now you know, give butyrate, done. Dietary change, fiber. But check this out. You're not going to see this every day. These are her commensal bacterial markers. Look, low, low, low. Let me just read these out. Low, 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 low. Undetected, 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 low, undetected, low, undetected, 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 low, undetected, low, undetected, undetected, low. Okay, the last one is okay. There's one that's okay. All right, so if you have like 23 out of 24 bacteria that are either can't be found or are really low, that's a major problem with your microbiome. And then would you be surprised that there's organ issues and infections? Not really even a little bit, based on what we just said. It's a brand new lab. We just looked at this morning. Okay, it's one of the doctors in the class. This is her test. One of the doctors in the class. Let me say that again. This is her test. And I want someone to ask me a question. Does she have any GI symptoms? Nope. She has no GI symptoms. None at all. No GI, can I say that again? No GI symptoms, none at all. Why did she do the test? Because she's in the mentorship class, and it's kind of part of the class to do the test. So test yourself for sure. Okay, so let's go back here. I'm going to wrap this up. So what are we going to do then? Well, now this person has all three problems. So we're going to use our butyrate. And I use it in the liquid form. It's done by the teaspoon. And then prebiotic powder. That's usually done on an empty stomach, like right here, 1 scoop. And then a probiotic. I don't know, let's just keep it easy. Let's say like Espelardi. Like 2 with breakfast and 2 with dinner, something like that, okay? So then That takes care of the microbiome part. So with SIG-A, you want to use an IgG-based powder to get the SIG-A to balance out. And that's usually, again, going to be like 1 scoop. And you could do 2 scoops a day with some of those, depending on the brand you're using. And then some gallbladder support. Again, let's say you do 1 of those with each meal. And then you're going to wait, clean up the diet, give it a month or 2 to strengthen the system. And then you're going to get aggressive about treating the parasites. If you have parasites and yeast both present at the same time, general rule of thumb is to treat parasites first. And you have to decide, is this a medication moment or is this a herbal moment? Or are we going to do both? That's a complex decision to make there. And then you're off and running. So I would do this top part of the program for the first month or 2 while you're doing all the lifestyle changes, and then hit really hard once your patient's starting to get a little bit better and knock the parasites out, and then deal with the yeast at the end. That would be the basic treatment sequence for a patient like that, all right? So I'm going to officially wrap this up by showing you once again, and thanking Genova, by the way, for helping us put this on. They're just the best lab to work with. I just love them, and I've known them all for a long time. I just appreciate their support so much. I really mean that in a lot of different ways. And if you want to do the boot camp that's coming up, you get a 20% discount. Just do your little code scanning thing right there, okay? And let me then open it up for questions. So we're at the hour right now. We're officially over. If you got to run, I get it. But let me go to the questions section now. Well, I had told you I'd take a glass of water first here. All right. Let's go to the top. How to choose the best right probiotic. You can base it on the, like if the lactobacillus is low, give lactobacillus. If the bifidobacteria is low, give bifidobacter. I personally think that's a little overly complex in that the gut's more nuanced than that. So I would just get a good quality probiotic. There's 3 different kinds. Espellardi would be one type. What I call like a regular probiotic, like a lactobacillus rhamnosus kind of thing. And then a spore-based probiotic. Those are the 3 different types. And just choose one of those for each patient that you might want to use. My favorite in general for most patients, it would be Espellardi. If I was going to start with something, that's a really good one to start with. They work really well. Someone has to show the QR code again. I just got that up there. It should be good. We talked about athletes already for Brittany. High school endurance athletes, yeah, you can make a huge difference with people if you get their microbiome working right if they're athletes. Yeah, this is all recorded, so we're going to send you a copy of the recording. Let's see. So if a person's on a medication when they're doing the test, like they're on a PPI or they're on an antibiotic, that's going to definitely impact the results. So that's going to depend on the timing and what drug they're on. And you can just, I would check with the lab specifically on those things because there's some nuances there, okay? That are going to depend on the case that you're dealing with. If the person has no gallbladder, you can totally help people without gallbladders. That's not a problem. Let's see. Do you look for yeast? Absolutely. There's yeast on this test. We saw that with that last case there. Do you include add-ons? Oh, good question. Thank you, Erica. So there is one add-on I would always recommend that you do. There's one add-on I would always recommend that you do, H. pylori. Take your regular GI effects test, always add H. pylori to it. It's worth the extra few bucks. The best fiber for the short chain fatty acids, any kind of fiber really just depends on what the person tolerates well in terms of taste and if it causes bloating or not. So you can just go to your favorite supplement brand and pick out 1 or 2 different options and have them try them and see which one they tolerate the best. Oh, Anne is asking, in that cycle, are some of those bacteria coming in after prolonged fasting? Oh, that's so deep. So when we fast for 12 hours or 24 hours, what happens to these bacteria? They die off in mass. They die off in mass. They completely fluctuate based on what you eat. Every meal makes a difference. In fact, Dr. Lord was saying a few years back when he was running the lab, they would, obviously they had access to free testing, and so they tested like lots of people just for fun. And in 2 or 3 days, you can completely change the commensal bacterial markers on here just with diet alone, maybe 3 or 4 days. If you stop eating all vegetables and fruit and fiber containing products, I don't know, just eat like hamburgers every day or something, it'll completely change your microbiome in 3 or 4 days. And the converse is true too. If you've been eating a Burger King everyday kind of diet and you all of a sudden hit the broccoli and blueberries and cranberries and cabbages of the world and eat some lentil soup for 3 or 4 days, it'll completely shift your microbiome. It's a day by day kind of thing, meal by meal kind of thing. So SIBO, with SIBO, you want to rule out 2 very important things before you do any SIBO treatments. Number 1, treat them for yeast. Number 2, treat their gallbladder. A yeast overgrowth will mimic or trigger SIBO, and a gallbladder problem, a lack of bile in the small intestine, is going to lead to small bacterial overgrowth in the gut every time, okay? Oh, and then here, let me show you here some of the products. So you can take snapshots of these. This is for stage 1, prebiotics, probiotics, butyrate, dot, dot, dot. Stage 2 for the organs, snapshot. I can hear your cameras clicking away. And then here's for the gut repair powders, right? That's for Evelyn. How do you order this test? You can just set up an account with Genova Labs, like right now. You get off this call and email Genova and get an account set up and order it. If you're not a licensed practitioner, you can order the test from Genova Connects. Direct to the public sales go through Genova Connects. Let's see. Oh, fatty acid genetic issues. Yeah, I'm really into that. I don't have time, Stacey, to talk about that now, but for another day, for sure. It's a very important issue. H. pylori and Pseudomonas. So for H. pylori, hands down, where I've seen the most success is with mastica gum. Anywhere from 500 milligrams to 1,000 milligrams, breakfast, lunch, and dinner for H. pylori. That's what I've seen be the most successful, okay? So in the GI course, there's videos, and then there's live Q&A where we're reviewing your labs. I don't remember how many hours it is, but it's 6 weeks long. So each week you probably have a couple hours of stuff. Any suggestions on immune powders? Yeah, any of the companies will have it. It'll have IgG in the description. IgG boost, IgG protect, IgG support, whatever. They're relatively interchangeable. I don't think there's one company that has a better one. Richard Lord's book, so the one on the gut health, and if you Google, Richard Lord, it's sold either through Apple Books or Google Books, and it's the one on gut microbes. It's the one that we're talking about here. Let's see, I think colostrum works equally well to the IgG powders for Evelyn there. Let's see. And let me see, we have one more minute here to try to get through these. Oh yeah, Dr. David asked a really, really good question. That patient had 0 inflammation with all that missing good bacteria. That's a really $1 million question. We talked a lot about that this morning. So for Dr. David, very observant of you. Guess what? Super clean diet. Super clean diet. Vegetables, fruit, plant-based diet for years and years and years. Super athletic, very physically fit doctor. And her history, I didn't really get into the history much, but on antibiotics constantly as a child, and then a lot of international travel, like a lot, years and years of living overseas. And I think she said 2 rounds of amoebic dysentery, many other gut infections, and many, many, many rounds of probiotics for all the gut infections that she had. But that was a tough lab. In fact, we don't really know what's happening with her. I suggested that she do some additional investigation on that because that was a tough one. The one that I showed with the low commensals, that was an unusual pattern that we hadn't really seen very often. So when you're killing pathogens, you can either start with medications and then do follow-up with herbal antimicrobials, or start with herbal antimicrobials and follow up with medications. But I would never do this two together at the same time. Some people may just need medications only and be done, and then some people may just need antimicrobial herbals and then be done. But if you're going to combine them, you would want to separate them in time. So you can't really tell if SIBO is present based on the GI effects. There's some patterns that may present it, but really probably just better off doing a SIBO test. And all this is recorded. You guys will get copies of the recording in your email box. Just check your email box tomorrow. Oh yeah, Entamoeba histolytica. That's one of the few bugs that I would always recommend people use medications for. So E-histo, one of the few bugs in the gut that I've really only seen success with antibiotics. You know, maybe some people that can fix it without them, but so the IgG powder you can use if the SIGA is low or high, either way. And let's see here. I'll just make some notes to individuals here. Specific questions. Let's see. Yeah, any age range, anyone who has stool can do the test. So it could be a 2-year-old kid, could be an 82-year-old. Doesn't really matter about the age there. We've tested a lot of kids in the 2, 3, 4-year age range who are having tummy problems. Okay. I think we're running out of time here, but there's a ton of really great questions. I'm sorry I can't get to all of them today. Those of you that are asking a ton of questions, take the boot camp. It's not that expensive. It's not that long, and you can ask a million questions there. We'll have much more time to go over all that stuff, okay? All right, take care, everyone. Thanks for participating. Appreciate it very much. All right, bye for now.